In previous discussion, we see the waveforms in without overlap. Now we consider with overlap condition. What is a overlap condition first? So in with overlap condition, the inductance is presence. Inductance LC is present. In before we not taken as inductance, that is inductance L is equal to 0. Same configuration, 135 is a positive group, 462 valves are negative group, VA, VB and VC. So this is a current, the DC current, DC voltage base to neutral. So the with overlap, without overlap condition, the consideration of inductance or negligible of inductance. In with overlap condition, we consider the inductance effect. Because of the inductance effect, there is a some delay in a commutation process. Please observe the diagram with overlap and without overlap condition. Please compare both diagrams. Here also there is a inductance LD. So LC indicates leakage inductance of the transformer VD. ID is equal to DC voltage and current flowing in the line. LD is equal to DC side reactance. V1 is equal to voltage across the thyristors. P comma N is equal to positive and negative pole on the line due to the leakage inductance of the converter transformer and the impedance in the supply network. The current in a valve cannot change suddenly and thus commutation from one valve to the next cannot be instantaneous. It will take some time. Suppose in previous analysis thyristor 1 to 2, the current transfer from thyristor 1 to 2. Here before the current transfer position is 1 to 2 to 3. So for example, when valve 3 is fired, the current transformer from valve 1 to valve 3 takes finite period. That will take some time during which both valves are conducting. This is called overlap and its duration is measured by the overlap or commutation angle mu. Normally any two thyristors will be conducting, but in case of the current is transferred from positive valve to negative valve, here at a time three thyristors are in conduction mode, 1 2 3, just like this. Normally in positive group one valve is conducting, in negative group another valve is conducting. Normally this is a procedure, but in case of commutation process or overlap period, in positive group at a time two thyristor will be conducts at a time means that means 1 2 3 in conduction mode. In positive group 1 3 thyristor is conducting, in the negative group 2 thyristor is conducting. There is a overlap 1 2 3 at a time. Commutation delay, the process of transfer of current from one path to another path with both paths carrying current simultaneously, is known as overlap. The time required for commutation or overlapping, which is expressed in electrical degrees, is done with commutation angle represented by mu. During normal operating conditions, the overlap angle is in the range of 0 to 60 degrees, in which 2 or 3 valves are conducting. However, if the overlap angle is the range of 60 to 120 degrees, then 3 to 4 valves are in conducting state, which is known as abnormal operation mode. During commutation period, the current increases from 0 to ID in the incoming valve and reduces to 0 from ID in outgoing valve. The commutation process begins with delay angle and ends with extinction angle. It starts when omega t is equal to alpha and ends when omega t is equal to alpha plus mu. Del is the extinction angle. There are three modes of the converters as follows. Mode 1, 2 and 3 valves in conducting. That is mu is equal to 60 degrees depending upon the delay angle alpha, the mode. In mode 2, must just a point on the boundary of modes 1 and 3. Third mode, analysis of 2 and 3 valves. Conduction mode, generally overlap angle will be less than 60 degrees. So let us analyze this mode. Timing diagram in this mode, each interval of the period of supply can be divided into two subintervals. In the first subinterval, three valves are conducting, and in the second subinterval, two valves are conducting. Please observe the diagram. This is a timing diagram. Thyristors is in on position 3, 4, 5, 6, 1, 2. Omega t is your alpha plus 60, alpha plus 360. The timing diagram starting from 0 to 360. HDC equivalent circuit. This is the equivalent circuit of HVDC three-phase system. So this is a rectifier. The rectifier output is VD naught or cos alpha. Already we derived in with overlap condition. Without overlap condition, VD naught or output voltage at the rectifier cos alpha. This is a DC line. So this is the output voltage of inverter. VD naught I cos gamma. Cos gamma is a alpha is a firing angle. Gamma is a extinction angle. So this is a equivalent circuit of HVDC line. So RCR is a resistance of rectifier. This is a load resistance or line resistance. This is a inverter resistance which are having negative signs. So this is a rectifier output voltage, inverter output voltage. Characteristics of 12 pulse converter. So the combined operation of two 6 pulse converter is a 12 pulse converter. Normally we know. Normally the combining operation of 2 pulses is a 6 pulse. The combining of two 6 pulse converter is a 12 pulse. So here there is a 1, 3, 5, 2, 4, 4, 6, 2. Already we know. So this is another 6 pulse group having 1 dash, 3 dash, 5 dash, 4 dash, 6 dash, 2 dash. So the transformer connection is star to star with star to delta. So this is a overall 12 pulse converter. So this is a 1:1 transformer. This is a 1:√3 transformer. So whenever the connection must be in star to star or star to delta, then only the two 6 pulse connected are in series. Then only the phase shift is possible. Then only a combining operation is possible. So the region of rectifier operation can be divided into 5 modes as mode 1, 4 and 5 valve conduction, mu lies in between 0 to 30 degrees. In mode 2, 5 and 6 valves conduction, mu lies in between 30 degrees to 60 degrees. In mode 3, 6 valve conduction, alpha lies in 0 to 30 degrees. Overlap angle mu is equal to 60 degrees. In mode 4, 6 and 7 valves are conduction. Overlap angle mu lies in between 60 degrees to 90 degrees. In mode 5, 7 and 8 valves are conduction. Mu lies in between 90 degrees to 120 degrees. The equivalent circuit of the 12 pulse converter is the series combination of the equivalent circuit of the two bridges. This is because of two bridges are connected in series on the DC side and in parallel on the AC side. So this is the output waveforms of 12 pulse converter. The combining of two 6 pulse converter generate output voltage. This is a line current output waveform stepwise. This stepwise possible only the transformer connection. Only the combining of two waveforms. Output waveform, star to star connection output waveform, star to delta output waveform. Then only in a combining operation is possible. Please observe the waveform of 12 pulse converter. Compounding of converters. The converter operating equations for the voltage Vd and current Id are expressed as follows. Vd is equal to 3 root 2 e by pi cos alpha plus cos omega. Id is equal to e by root 2 omega Lc cos alpha minus cos omega. This is a whenever the omega is varies from 0 to 90 or 75. Whenever the alpha is varies, alpha is 180, alpha is 165, omega is 165, omega is 185. Whenever the alpha and omega values varies, how the characteristics will be obtained. These are characteristics of voltage versus current characteristics. Whenever the extinction angle gamma is in 15 degrees in first mode, 30 degrees second, 45 next, 60 degrees on next. So this is the characteristics of converters. This is a characteristic diagram of converters. Please observe carefully. Characteristics drawn in between Vd versus Id. It is useful to draw the converter chart in per unit. For this purpose, the natural selection for the base voltage is the maximum direct voltage output Vd naught. There is no such natural current base, thus it is convenient to select the constant appearing in equation for current as the base quantity. Okay, thank you.